All right, good morning, everyone. Mr. B here. Today we are going to be doing some math together. Normally, I'm going to be recording on the whiteboard at school, but because I'm at home and I don't have a whiteboard here at home, yeah, I know teachers don't have whiteboards at home. Maybe some do, but I don't. I'm going to be doing it with just marker and paper today. So you let me know if you like this type of format. You can let me know in the comments section or in Google Classroom. If you don't like this, maybe you'll like the whiteboard one better that you'll see in the next video. But I wanted to have this ready for you guys for Monday morning, so here we are. We just finished perpendicular and angle bisectors in class using the compasses, and we'll continue a little bit of that when you guys get back in 2 weeks. I really hope we get back in 2 weeks because I prefer to teach in person. But we're going to start a little unit today, kind of an extension unit on area and perimeter. So what I would suggest having today is make sure you have some loose leaf. You can pause this video at any time. So if you want to go grab some loose leaf in your math section, and I would highly recommend having a pencil. I remember, if you're missing any types of supplies, let me know. I can get a package together for you to come and pick up at school, but I did encourage everyone to take that on that last Friday. We're going to take down just a few little notes today, and then we're going to do some examples. Now, these examples today will help you with the following 3 worksheets. The first one is a practice one, followed by a set of textbook questions, followed by a worksheet. So you could always refer back to this video, skip to certain sections of the video. If you read the description of the video, I will have right in the description where I start each section. So today, let's get started with what is area and perimeter. So the first thing is perimeter. Would you look at that? I start with a marker that's already kind of dying. That's so me. Do that. But perimeter is very simply the distance around a shape. So when we talk about perimeter, we're just simply talking about the distance around something. You might say the perimeter around the school, the perimeter around my yard, the perimeter around, well, a great example is some of you guys know the perimeter highway, which is just a highway that goes around the city of Winnipeg. Yes, I know in certain parts it's spilled over, but generally speaking, we call it the perimeter because it goes around. If you're in Regina, they call it the ring road, but it is the perimeter. So if you have a shape, let's just pick a very simple one here, a rectangle. The perimeter would be the distance around the shape. Excellent. And with perimeter we are measuring essentially lines. So this is a one dimension. Abbreviate there. So when we measure perimeter, we're measuring in a single dimension because it's just simply the lines that go around a shape. So again, for perimeter, it's just simply the lines around the shape. Very, very, very straightforward. Now, when we get into area is a little bit different than perimeter, and we're really going to be focusing on area in our unit this time around for grade 7. For perimeter, it's just a simple matter of adding up all of the sides. So for example, if this was a rectangle, and let's just say this side was 6 centimeters, and this side was also going to be 6 because it's a rectangle, which means this side, if it's 3, this side here is also going to be 3. So to get the perimeter, we just simply add them all up. So in this case, it'd be 18 centimeters because we would add 6 plus 6 plus 3 plus 3. But that's generally it for perimeter. But we're really going to be focusing today on area. So again, if you copy this down, that would be great. And I suggest if for whatever reason you are going a little slower, just pause the video, hit play whenever you're comfortable. When we get to area, I apologize, I'm using an old workbook here. Area is the distance, or sorry, we should better instead of distance, it's the space inside a shape. So if perimeter is the distance around it, area is the distance inside the shape. So again, let's go with a shape that we already started with, which is a rectangle. I'm freehanding it here, so bear with me. I know it's not great. I already see it's off, but that's okay. So area would be the distance, or the space, I should say, inside the shape. Not around it, but inside. That's what area is. And this area we measure in 2 dimensions. Because not only do we have one measurement, such as length or width, but we have another measurement, which is height. So area, unlike perimeter, is 2-dimensional. And we'll kind of explain how that works as we go on. But area is, very simply put, the space inside of a shape. And it's 2-dimensional, and we measure it with something called squared meters, centimeters, whatever, but it's a squared measurement. And we'll talk about what that squared measurement means in a second. But for example, if our answer was 12 centimeters, we always want to put a little small 2 there to show that it's squared centimeters. And we'll talk about that in a moment. But when we measure area of any shape, whether it's a triangle, whether it's a trapezoid, whether it's a rectangle or a parallelogram, which is just another type of rectangle, but whenever we work with area, we're working with what are called squared units. So for example, we're trying to figure out how many little squares, or 1 meter squares, or 1 centimeter squares, or whatever, can fit inside the shape. So that's why when we put our answer, we always put 12 centimeters squared, because we're trying to figure out how many small squares can fit into that said shape. Now, with area, it really, again, depends on what type of shape we're working with. And we're going to be working with 3 major ones this term. And then we'll be working with something called irregular shapes. But we're going to be working with parallelograms, triangles, and trapezoids. And then we will start to put those together into irregular shapes. But we're going to start with parallelograms. Now, this is a very fancy word for something that you see all the time in your everyday life. There we go. So a parallelogram is simply a 4-sided shape with 2 equal and parallel sides. So it's 4-sided. Now, when we think of 4-sided figures, the most common ones we think of are squares and rectangles, and these are essentially examples of parallelograms. But they don't always have to be perfectly square or perfectly rectangular. So, for example, we might think of a square. We might think of a rectangle. Or we could think of a parallelogram, which is another type of one of these shapes. Now, all of these shapes have 4 sides. All of them have 2 equal sides that are parallel to another 2 equal sides. Now, a square has 4 equal sides, so all the sides in a square equal the same. A rectangle is going to have 2 that are the same and 2 that are opposite but the same, and it's the same here with this type of shape, which we refer to often as a parallelogram. The only difference between a rectangle and a parallelogram is that the sides in a rectangle are 90 degrees, whereas the sides in a parallelogram are not 90 degrees. But these are all examples of parallelograms. So sometimes when I say that word, I could be referring to any of these shapes. The only difference here is that with a square, all the sides are the same. With a rectangle, 2 sides are the same, but parallel, and then another 2 sides are the same, but parallel. And then in an actual parallelogram, we have the same type of thing. The only difference is there's no 90-degree angles here. Now, when we look at parallelograms, or any of the shapes in the 2-dimensional category, whether that's triangles or trapezoids or whatever, there are some units that we can use to help us measure, or some indicators of those. Now let's just go here to our rectangle here. So we have a couple of different things we can measure here. The first one is what we call length. Another name for length that we're going to use more is base. So we have the length or the base of this shape, and the opposite side is also considered to be the length or the base. You might have noticed the opposite side here, we refer to that as the height. So we have, and then this side here would also be the height. Okay, so we have length or base and then height. And because all these sides are parallel and equal, as long as we know one, we essentially know the other one. So that's the kind of nice thing about working with these types of shapes. Because they're parallel and equal, the sides are going to be the same. Now, we use a formula that can be used for any one of these shapes that we work with to help us find the area or the amount of space inside of the shape. Okay, we use a very, very simple formula. And to show you how that works, I'm going to draw on here. I'm going to switch to red here. Now, let's say that each one of these is 1 centimeter. Let's just draw that out here. I know it's not going to be perfectly equal because I am freehanding this, so just bear with me on that one. There we go. So imagine that each one of these is a 1 centimeter box. I realize I freehanded it, so it's a little bit off. Let's count and find out how many are each one. So if I look here, I have 1, 2, 3, 4, 5, 6, 7. So my length is 7 centimeters since each one of those boxes is a centimeter. Now the height is 2 centimeters. So the height is 2 centimeters. Okay. Now the question is how many are in total? Well, you could just add them up, which is one way to do that, or we could multiply them together, which will give us the exact same answer. And multiplying this is a little bit easier than counting them up, especially if they're not drawn on the shape and you have to draw them out yourself, which does take a little bit of time. So we can use a formula here, and the formula that you're going to use, and I really encourage you to copy this down, is we're going to write the letter A, which stands for area. So the area will equal the base times the height. Now, I used brackets there. Brackets are often used in algebra. We're going to talk about this a little bit more. Algebra, remember we talked a little bit before the break, is finding a missing number or a missing letter. And in algebra, we often use the brackets just to show multiplication. You could easily just write B times H. But because we use the letter X in other areas, it's usually just good to put the brackets around. So I start all my problems off with area equals base times height. And I'm going to write that out for you here. So area, so the area of this shape is going to be the base of the shape times the height of the shape. The base and the height. So for this particular shape, we don't know the area. We're going to put area equals. But we know that the base here is 7 because we counted it. So the base is 7. And we know that the height is 2 because we counted it there. So we're going to go 7 times 2. So area equals, and 7 times 2 is going to give us 14 centimeters squared. Because remember, each one of these is a squared centimeter. And if we count them up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 centimeters squared. So when you're asked to find the area of a shape, and if it's a parallelogram, we can use the simple formula of base times height. If you're ever doing, this is a very practical way to do this, is if you're doing flooring in a house, or you're doing you're putting up paneling on a wall. For example, we renovated our basement last summer and we needed to replace the carpet. So I measured the base of the room and the height of the room, and I multiplied them together, which gave me the area, which allowed me to figure out how much carpet I would need to use per bedroom. And then I measured all my bedrooms and added them up. So 14 centimeters. Now this is, let's try one more together here. We're gonna try a few of them actually, but we're gonna work on a little bit of a different variation of the rectangle. So let me just flip my page here. High technology I'm using here. A camera with a notebook. All right, we're going to work with a little bit of a different shape here. This here is a parallelogram. It has two sides, four sides in total, just like a rectangle. These two sides are equal, but they're parallel each other. And then these two sides are equal and they're parallel each other. So I've drawn a grid here. And the first thing we can do is we can apply the exact same formula, but let's find the base and the height. So if I count here, 1, 2, 3, 4, 5, 6, 7, I have 8 centimeters here. And if I count the top, it should be the same. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so it's 8 on the top. And let's count the height. 1, 2, 3. And you might look here and say, well, there's only 2 here. Yes, but technically this would extend down here as well. And again, same here. This would technically extend up here as well. So we have a total of 1, 2, 3. Now, this is where I want to make something clear. When we looked at our rectangle, it was very obvious. So let's just draw that rectangle again here. When we looked at our rectangle, because it's a 90-degree angle, it's really obvious what our height is. Okay, very, very obvious. So our height is 2 because it's 1, 2. But when we look at this shape, the height isn't the side length like it is here. This is the side length, but the height isn't the side length here. It's the distance from the base to the other base, okay? So that's where it gets a little more confusing when we work with a shape like this. The base is simply, or the height is simply the distance from here to here, which is 1, 2, 3, okay? Again, if I looked over on the side, it would be the distance from here to here, which would be 1, 2, 3. Okay, so working with a rectangle, it's really obvious where that height is. It's simply 1, 2. But when we're working with a shape like this, a parallelogram, it's because our shape is kind of angled this way and the side isn't 90 degrees, we have to make sure we measure from the top to the bottom. So it's 3. So let's go back to that formula again. Area equals base times the height. And we know that the base is 8 centimeters. We already counted it out. We know that the height is 3 because we counted it out. And when we multiply 8 times 3, we get 24 centimeters squared. And if I counted all of these, I would get 24. But remember, I have to factor in the fact that this is technically going to go off here because this shape is angled and not at a 90-degree angle. It's slightly slanted. Now, normally when I give you these types of questions, I'm already going to give you the measurements. You're not going to have to draw out a grid. There will be a few, but they'll be relatively obvious. But you'll have to, normally you'll be given the measurements here. And you just need to apply the formula, base times height, 8 times 3, 24 centimeters squared. Let's try a few more, just as some practice questions here. All right, let's go to we'll work with a rectangle here. And I'm going to draw a little grid for you here. Now, what I want you to do here is pause the video and try this one on your own. Count the amount of squares on the base, count the amount of squares on the height, and use your formula, base times height, to give yourself the area. So pause that and then come back and we'll see if you did it right. Okay, guys, so if you counted here, you would have got 1, 2, 3, 4, 5, 6, and 7 centimeters as your base. 1, 2, 3, 4, 5, 6, 7. And your height would have been 1, 2, 3 centimeters. Okay, so we would have went area equals base times the height. Area equals, the base was 7, the height was 3. And finally, area equals 21 centimeters squared. So hopefully you were able to do that correctly. Now, the reason I want you to actually draw this out is because as we work with other shapes, there's going to be different formulas. And I want to make sure you're using the correct formula. So when I see your work completed, I want to see all of this drawn out like this. It should be 3 lines. Your formula, filling in what you know, and then your answer at the bottom. So the area is 21 centimeters squared. Let's try another one. together here. Like, hopefully you're copying these down and trying them out on your own. It'll really help you when we go start to do them. I'm going to draw another very poorly drawn parallelogram. I apologize. There we go. And we're going to draw a grid for this one as well. There you go. So pause the video if you want, count out the base, count out the height, and use your formula base times height. Give it a try now. All right, so if we count it out, you should have went 1, 2, 3, 4, 5, 6, 7 centimeters again. And this time height of 1 and 2. And there is our measurement. So our formula would simply be area equals base times the height. The base is 7. The height is 2. And 7 times 2 gives us 14 centimeters squared. And that is our final answer there. So hopefully you were able to end up with 14 centimeters squared. All right, we're going to try maybe one more. So let's go flip here. And after that, you should be ready to kind of give this a whirl on your own and go and try the practice questions out. So I am really not great at... I'm much better at freehanding on the whiteboard, as probably some of you would have noticed. Not so much on paper. Here's an ugly parallelogram here. Again, I apologize for that. But you get the point, I hope. All right, I want you to give that one a try. Use your formula, count the base, count the height, and use your formula base times height to figure that out. All right, hopefully you're able to do that. Let's count here. 1, 2, 3, 4, 5, 6, and man, 7 again. 1, 2, 3, 4, 5, 6, 7. I don't know why I keep counting 7s. It's like a total fluke here, but I keep doing 7 for some reason. And then the height, remember, on this shape, it's the distance from the top to the bottom. So let's go 1, 2, 3, 4. So it's 4 centimeters. So our formula would have been area equals base times height. Area equals 7 times 4. And area equals 28 centimeters squared. And that's all you have to do there. Now, I know some of you are going to look and go, well, that's not really a square. Yes, technically it's not. But remember, we also have more on this side to fill out. And because these will normally go off the paper, they do actually fill out in total. Now, I can't do it on here. Normally on the smartboard, I would be able, or on the projector at school, I could show you this. But here's an interesting thing. If I took, I'm going to redraw it here for you on a separate piece of paper. Because it's hard to visualize this unless I use the projector at school. Okay, imagine if I cut this out. Imagine if I just made this a triangle and I cut it out and I got rid of it and I shifted it over here. It would fit perfectly here. Okay, it would fit perfectly there. So it would technically make this shape a rectangle. Okay, and remember, with a rectangle, the side length here is also the height. And that's one thing I want to keep in mind to let you guys know about, is with a rectangle, the base is always sort of here and the height is the opposite line. But on a parallelogram, that's not the case. Okay? This is still the base, but this line is not the height, okay? The height is the distance from the top to the bottom. It's not this side length. It is in a rectangle because it's 90 degrees, but it's not here in a type of parallelogram. So just keep that in mind. Now, the practice sheet you're going to get today is going to have a number of questions like this. You're already going to be given the measurements. Use your formula, area equals, and fill in the base and the height, and go ahead and do those steps. Everything after this is going to be more in-depth stuff that you'll need for the second and third worksheet. So you may want to refer back to this video then to help you with some of the word problem questions that you're going to see. Anything else, you can definitely message me and we can talk together, but watch the video a few times and try to work on the examples and it should help you through it. All right, guys, hopefully this helped to get you started. And if you want to keep watching to see how to do the word problems for the other ones, you can do that tomorrow or the next day or whenever you have time. That's it for now.